Hello, my name is Mr. Asprey and this is EDEXCEL A-Level June 2023 Paper 2. And before we get into it, do look at the description because I've put all of the links there to all my playlists, such as all the past papers. I do a Trig Equation series, which is really good, check that out. And I also do predicted papers, which are really helpful during the exam period. And during the exam periods, I also do live revision sessions as well. So you can check those out. All of that stuff is in the description, including just extra videos and a Google file as well, a Google link drive, which has all my resources in. So do check that out. And if you do think it is good and you like this video or whatever, then please do consider subscribing to the channel. That would really help me out, and like and share. Okay, let's get into the maths. Find the second derivative of the function f of x. So in order for us to do that, we first need to find the first derivative, f dash of x. So the 3 comes down to the front, and we drop the power down by 1. The 2 comes down, times by the 2 already there, gives us 4, drop the power down by 1. And minus 8x differentiates to minus 8, and the constant 5 differentiates to 0. Now we can differentiate again to find the second derivative. So the 2 comes down, times by the 3 to get 6, drop the power down by 1 to x to the 1. 4x differentiates to 4, and the constant minus 8 differentiates to 0. Lovely. There we go. Part B. Solve the second derivative equal to 0. Okay, so the second derivative we know is equal to 6x plus 4, and we're setting that equal to 0. Which means 6x equals minus 4, so x is equal to minus 2 over 3, where we divide through by 6 and then simplify. It says, hence find the range of values for x for which f of x is concave. Okay, so to be honest, I can't always remember which one is which, so let me just show you what I would do. Concave looks like a cave, so it's like a tunnel. So it's this type of shape to it. And what happens to the gradient as it goes round there? The gradient starts off very steep, so a big positive number, and then it decreases, and it gets to 0, and then the gradient starts becoming negative. Okay, so that means that the gradient is decreasing, which means the second derivative must be negative. So we are looking for when f double dash of x is less than 0. And we know that f double dash of x equals 0 here. So any values which are less than that would therefore give the second derivative being less than 0. So the solution is that x is less than minus 2 over 3. Perfect. Okay, question 2, and we have the first term is 35, and then the next term along, you take the previous term, and then you plus 7 lots of n pi cos n pi over 2 minus 5 times minus 1 to the power n. Okay, show that u2 is equal to 40. Okay, well, let's first off find the value of n. So if we're going to find u2, we're going to use this formula, which is for un plus 1. So in order to make un plus 1 u2, n must equal 1, because we're setting these equal to each other. So n plus 1 is equal to 2, so n equals 1. Okay, so we can say that u2 is equal to, if n is 1, then that's u1 plus 7 lots of cos n is 1, so that's pi over 2, minus 5 lots of minus 1, again n is 1 to the power 1. Okay, so u1 we know is 35, plus cos of pi over 2 is 0, so that's just 7 lots of 0. I'll just put it in there because it is a show that question, so I want to show all my working. Minus 5 times, and then minus 1 to the power 1 is just minus 1, times minus 5 is plus 5. And this clearly equals 40. So we are good, that is done. Brilliant. Okay, part 2. find the value of u3 and the value of u4. Okay, so u3, we're going to do exactly the same thing. This time n is going to equal 2. So we're going to do u2, which we know is 40, plus 7 lots of cos 2 pi over 2 minus 5 lots of minus 1 to the power of 2. Okay, so this is going to give us 40. Now cos of 2 pi over 2 is the same as cos of pi, which is minus 1. So that's going to give us minus 7. And then minus 1 squared is just 1, times by minus 5 is minus 5. So this is going to give us 28. Yeah, perfect. Okay, so next we need to find u4, and of course u4, again by the same logic, is when n is equal to 3. So that's going to be u3, which we know already is 28. So let's just put that straight in. So it's 28, and then it's plus 7 lots of cos of 3 pi over 2 minus 5 lots of minus 1 to the power of 3. So this is 28, and cos of 3 pi over 2, again thinking about the graph, that's 270, so that is 0. So that's just 7 lots of 0, and then minus 1 cubed is minus 1, times by 5 is plus 5. Sorry, minus 1 cubed is minus 1, times by minus 5 is plus 5, yeah. So this gives us 33. Okay, great. Seemed like a lot of work for 3 marks, but hey ho. Given that the sequence is periodic with order 4, okay, write down the value of u5. Fine, so that means if it's periodic with order 4, it means it's going to be a set of 4 terms which is going to repeat. So the first term being 35, the second being 40, the next one being 28, and then the one after that being 33. That's the set of 4. So the 5th term, or u5, is going to go back to the beginning. So it'll be 35. So we can say for b part I, u5 is equal to 35. And then it says find the value of the sum of the first 25 terms. It means first because it means we're starting with the first term and we're going up to the 25th term. Okay, so we're going to think about that as sets of 4. How many sets of 4 do we need to get up to 25? Well, if we have 6 sets of 4, that will get us to 24. And then the next term will be the first term of the set, which will be 35 again. So we're going to write this for part 2. The summation up to 25, starting at 1, of this series is equal to 6 lots of this set of 4 added together, plus the 25th term, which will be 35. Okay, so we'll do that on our calculator, and we get a value of 851. Perfect. Okay, question 3, and we have a log question, and we need to turn it into a non-log question. Now, luckily, all the logs are the same base, so which means we can move them all to one side and then collect them. So I'm going to write this as log of x plus 3 plus log of x plus 10, and then minus 2 log of x, and again these are all base 2, and that's equal to 2. Okay, the next thing I'm going to do is I'm going to collect them all up. Now, before I do that though, I will need to write, I need to change the fact that there's a coefficient in front of this one. So I'll write that as log base 2 of x squared, using that log rule that the coefficient can become the power of the input of the logarithm, and vice versa. Now we can collect them all together, because when we add logs together, we can multiply their inputs as a single log, and when we minus logs, we can divide by that input to make it a single log. So the single log is going to be x plus 3 is positive, and so is x plus 10, so we're going to times those together, but the x squared one is negative, so we're going to divide through by the x squared one, like so. And that's equal to 2. And now we need some sort of understanding of what logarithms actually are, so it might be useful just to write out the rules of logarithms, which is that if we have log of base a of x is equal to n, then this is telling us that a to the n is equal to x. So that's how we write it as an indice. So in this case, we have, we don't know what x is, this big thing in here. N is 2, and the base is 2, like so. So we can say that a, which is 2, the base, n, which is the power 2, is equal to x, which is our big quadratic-y thing. So that's equal to 4. So it means the yellow bit is equal to 4. Okay, so we can say that x plus 3, x plus 10 over x squared is equal to 4. We can then multiply through and multiply out as well. So let's multiply out the brackets on the top. We get x squared, we're going to get 13x plus 30, and we're also going to multiply both sides by x squared to clear that denominator. And then we're going to bring everything over to the right hand side in order to get a 3x squared minus a 13x and minus a 30. And that is exactly what we need. I can see it right at the top there, perfect. It then says, hence state which of the roots in part BI is not a solution of this. Give reasons for your answer. Interesting. So we can factorize this, I believe. So let's just do that quickly. So we have 3x, x, and the factors are going to be, I've got it, minus 18 and plus 5, that's not right, minus 6 and plus 5. Yes, that's perfect, that works out nicely, just double checking. Yes, that works out perfectly, lovely. Okay, so that gives us x is equal to minus 5 over 3, or x is equal to 6. Now, you can't take a logarithm of a negative number. So we're going to say that x does not equal minus 5 over 3 as log, and we can see here at the top, just slightly out of picture, but here, we will need to take log of x. Okay, so we will need to take log of x because of that thing there. Log of base 2 of minus 5 over 3 is not real. You can't take the log of a negative number. Okay, question number 4. We've got coffee is poured into a cup. Ugh, I hate coffee. The temperature of the coffee after being poured into the cup is modelled by the equation. Fine. Initially, the temperature of the coffee was 85 centigrades. Okay. Find the value of A. So initially means that T is equal to 0. So what we can say is T is equal to 0 gives the temperature H, which is 85 at that time, is equal to A e to the 0 plus 30. So therefore 85 is equal to, e to the 0 is 1, so just a plus 30. So therefore a is equal to 55. And make sure you put the units in as well. So a is 55. Okay. Initially the coffee was cooling at a rate. Ooh, important, the word there, rate. That means I'm going to take a derivative of 7.5 degrees centigrade per minute. Find a complete equation for h and t, giving, okay, fine. So, like I said, the rate means we have to differentiate. So dh by dt is equal to, so we're differentiating an e function, which means we need to just keep it exactly the same, but we need to multiply by the derivative of the input. So the derivative of minus bt is minus b, so I need to multiply through by minus b. So that's going to give us minus ba e to the minus bt, and the 30 is going to disappear. Okay, so we've just differentiated, and now we need to sub in. Now it says initially, which means that t is equal to 0, and it says that it is cooling at a rate of 7.5, which is very tricky because that means that the derivative is negative because it's cooling, so the temperature is going down by 7.5 each minute, so the derivative will be negative 7.5. And okay, so we can sub in now. So minus 7.5 is equal to minus b multiplied by a, which is 55, multiplied by e, and t is 0, so e to the 0 is just 1. So we can just get rid of that. So b is going to equal minus 7.5 divided by minus 55, which is of course the same as just 7.5 divided by 55. Which is 3 over 22, which we'll leave it like that. Actually we won't, because it does say to 3 decimal places. So we will write it as 0.136. Okay, and then it says again, find a complete equation linking h and t. So I have to write the equation out. So we'll write h is equal to 55 for a, e to the minus 0.136 t plus 30. Okay, perfect. Question 5, and we've got a curve as the equation f of x. The curve passes through this point and it has a turning point at that point. Given that the derivative is equal to this, where k is a constant, show that k is equal to 12. Okay, so we know that it's a turning point at p, which means that the derivative is equal to 0. So we can say that at the point 3 minus 10, dy by dx equals 0, and that means that x equals 3. So we can say that 0 is equal to 2 lots of 3 cubed minus 9 lots of 3 squared plus 5 lots of 3 plus k. And again, it's a show that question, so I'm going to evaluate these things. So it's 27 times 2 is 54, 9 times 9 is 81, plus 15 plus k, which gives us 69 minus 18 is 12. I think that's enough. Yeah, we're good to go from there. K is equal to 12. Lovely. Perfect. Okay. So next it says find the coordinates of the point where P crosses the y-axis. So the y-intercept. Okay, so the point where C crosses the y-axis. Okay, so C is the function. So to find the function given its derivative, we have to integrate, because of course integration is the opposite of differentiation. So I can write that if I integrate both sides, dy by dx is equal to the integral of 2x cubed minus 9x squared plus 5x and then plus 12. We can multiply both sides by dx, like so, so that we have the integral of dy, which is just y. And on this side, we have up the power divided by the new power, so we're dividing by 4, so 2 over 4 is a half, so it's a half x to the power of 4. We up the power to a 3, divide by the new power, so we get this, up the power to 2, divide by the new power, up the power to 1, divide by the new power of 1, and we get plus c, the constant of integration, which is also going to be our y-intercept. Okay, so now we need a point on the curve to confirm this, to find c, and of course we have this point already here, so we can sub these points in. So y is minus 10, and then here I'm just going to show the examiner that I'm subbing in 3, nice and clearly, and then I think I'm probably just going to use my calculator to actually evaluate this to find c. Okay, so I've just subbed in this big chunk into my calculator and I've got 18, so perfect, so minus 18 for both sides, and I get minus 26. It does say hence find the coordinates, so I'm just going to be careful and I'll give my final answer as 0, minus 28, like so. Bosh. Question 6, and we've got relative to a fixed origin, we've got the position vectors of A, B, C and D. How generous. And it says show that AD is parallel to BC. Okay, so the first thing we'd have to do is work out what each of them are. So AD is equal to OD, the position vector of D, minus OA, the position vector of A, which is equal to 22I plus 24J minus just 12I. Okay, perfect, which gives me, I take the i's away, so I get 10I plus 24J. Okay, next one, BC is equal to the position vector of C minus the position vector of B, which is equal to 50I plus 136J minus 16J. So we just need to subtract the J's here, which is going to give us plus 120J. Now if they're parallel, then one will be a multiple of the other, and we can see here that BC is 5 times bigger in both the I and the J of AD, like so. So therefore parallel. BC and AD parallel. Okay. Lovely. The points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. The runners complete one lap by running along all four sides of the track. The lengths of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed of this runner, giving your answers in kilometers per hour, even though the sides are measured in meters. Really? Fine. So we're going to have to work out all of the sides, and so far, if we just do a quick sketch, like whatever the shape is. It's just as a quadrilateral, but whatever shape it is, it doesn't matter. But what does matter is the order of the sides. They must be in the correct order, because it does say Yeah, A, B, C, D are used to model the running track. Okay. And we know that BC is parallel to AD, so it must be a type of parallelogram like this. Fine. So, we know AD and we know BC already. So what we don't know is AB and DC. So let's find AB now. So AB will be OB minus OA, which will be 16J minus 12I. Perfect. And then the other one we'll need to find is DC, which will be OC minus OD, which will be 50 plus 136, so 50I plus 136J minus 22I plus 24J. Okay, so this will give us 28I and it will give us plus 112J. Now we're going to need to find the magnitude of each of the sides. So we'll start with AD. So the magnitude of AD will be the square root of the two components squared, so 10 and 24 squared, and then added together. And that will give us, actually I'll just calculate them all a bit later. Let's just write down what we're doing first. So BC will be the square root of 50 squared plus 120 squared. And AB will be the square root of 16 squared and 12 squared. It doesn't matter that it's minus, you're squaring it anyway. And DC, the distance will be the square root of 28 squared plus 112 squared. Okay, let me calculate each of these. Okay, so I've just put those all in my calculators, and these are the values that I've got. And now these are all meters, so I'm going to add these up. So the total distance is whatever I get when I add all these four up. And I've just done that and I've got 291.4. Okay, so that was the total distance of one lap. So 2 laps, of course, will be double this, which will be 582.8. And that's what they want to do. They want to do 2 laps and they want to do exactly 5 minutes, but we want it per hour. So 5 minutes is 5 over 60 hours, which is the same as 1/12. So it's 1/12 of an hour. So the average speed, of course, is equal to distance, which is this, over time, which is a 12. Like, careful though. This was meters. This 2 laps was meters. So we need to divide this by, we need to say this is equal to 0.5828 kilometers, dividing through by 1,000. So then to find the speed, it will be the distance in kilometers divided by the time in hours, like so. And doing that calculation gives us an answer of 6.99 kilometers per hour as our final answer. Wow, what a long question for 4 marks. Question number 7, we have a function in x and y, and we need to find the dy by dx. So that means that we're going to be differentiating implicitly. So we're not going to do that. We're going to look at each term and we're going to differentiate them separately. So x cubed, well, we know what that differentiates to with respect to x. It's 3x squared. Now, the next one is a product. It's 2x and y. So for the product rule, I'm going to leave 2x alone, and I'm going to differentiate the yellow bit y, which gives me dy by dx. And then I'm going to differentiate the blue bit 2x to get 2, and I'm going to leave the yellow bit alone to get y. And the next one is a function of y, so when we differentiate this, we're going to just differentiate it as though it was an x, so the 2 comes down, times by the 3, and drop the power down by 1, but then we always multiply through by dy by dx when we differentiate a function of y with respect to x. 47 is a constant, so that differentiates to 0. We're then going to factorise all of the terms that have a dy by dx in. So there's one that's multiplied by 2x, and there's one that's multiplied by 6y. And then we're going to move all the terms which don't have a dy by dx in it to the other side of the equation and make those, and change the sign obviously when we move them. So minus 3x squared minus 2y. And then we're going to divide through by this factor of 2x plus 6y to get minus 3x squared minus 2y all over 2x plus 6y. Okay, perfect. Part B. The point P lies on the curve. Find the equation of the normal to the curve at the point P, giving your answer in the form of ax plus by plus c, where a, b and c are integers to be found. No problem. Okay, so we're first going to find dy by dx at the point P. So in order to do that, we're going to substitute in the point P, x and y, into the function dy by dx that we found. So dy by dx is minus 3 times x squared, which is minus 2 at P, minus 2 lots of y, which is 5 at P, all over 2 lots of x, which is minus 2 again, plus 6 lots of y, which is 5. So I'm going to put that into my calculator. So I've put that in there, and that's given me minus 11 over 13. Okay, so therefore the normal gradient at P is equal to the negative reciprocal of that, so positive 13 over 11. Okay, nice. And now it's just about doing a straight line equation with the point P and this gradient. So the straight line equation is y minus y1 equals mx minus x1. You can use y equals mx plus c, of course, but this one is just more efficient, particularly when you are trying to get your answer in this form, and I'll show you why. So we have y, and the point P is a point on the curve and a point on the normal, so that's the one we're going to use. So the y value is 5. The gradient is as shown, and the x value is minus 2, so we're minusing minus 2, so it's plus 2. And now what we can do is we can take this 11 and we can multiply it to this side, and we can take this 13 and multiply it into this bracket. So it's going to give us all whole numbers, and it's just going to be nice and simple. So 11y minus 55 is equal to 13x plus 26. And then all that's left to do now is to move it all over to one side. I guess it doesn't matter which side. So I'll just put it all over to the right side, just to keep as many things positive as possible. So 13x minus 11y, and then add 55 to 26 is 81, I believe. Perfect. Okay, we're asked to express 2 cos theta plus 8 sine theta in the form r cos theta minus alpha, where r and alpha are constants. It says give the exact value of r and give the value of theta in radians to 3 decimal places. Okay, so I use a little hack here. Because we are looking at cos, we say that the cos coefficient is our a value, so a is equal to 2. So I say a is equal to 2, and our b is sine. So I say b is, in this case, 8 sine. Okay, so that's because cos is the one we're converting into, so the a1 is cos, so therefore the b1 is the sine. And then you can just use the formula, and that is that r is equal to the square root of a squared plus b squared, and alpha is equal to tan to the minus 1 of b over a. Okay, so this works every time. Don't worry about the sign, like here. Just completely ignore that, and just take the actual magnitude of a and b, the number. So this is the square root of 2 squared plus 8 squared, which is equal to the square root of 64 plus 4, so 68, which is the same as 2 root 17. And then over here, we just need to make sure that our calculator is in radian mode. So like so. And then we're going to do tan to the minus 1 of 8 over 2. And that's going to give us 1.326. Okay, brilliant. And then finally, I do just get a bit paranoid, so I would want to actually express it, just to make sure they don't mark me down, even though I've checked the mark scheme and they don't. But I think good habits is actually to write it exactly as they've asked us to express it, like so. Okay, perfect. So now it says the first 3 terms of an arithmetic sequence are given as this. Given that S9 represents the sum of the first 9 terms of this sequence, as x varies, find the exact maximum value of S9, deduce the smallest possible value of x at which this is a maximum value. I mean, that's quite a daunting question, to be honest, and for 3 marks, it's a bit like there should be more marks for that. But anyway, let's just break it down, because it says an arithmetic sequence, and it also says the sum of the first 9 terms. So we know that the summation of the first 9 terms of an arithmetic sequence is the number of terms over 2 multiplied by, in brackets, 2 lots of the first term plus n minus 1, in this case will be 9 minus 1, multiplied by d. So this is 4.5 multiplied by 2 lots of a. Well, the first term is cos x, so 2 lots of cos x, plus 8 lots, and d is what we're adding on each time. And you can see what you add on to get to the next one. It's a sine x, and then that carries on by adding on another sine x. So the common difference is sine x. Okay, and now we can hopefully see how this links into the question prior, because we have an expression for 2 cos of an angle plus 8 sine of an angle, which is exactly what we have here. So we're going to swap that out for the expression that we found in part A. So it's going to be 4.5 multiplied by 2 lots of root 17 cos, in this case we're not using theta, we're using x, so x minus 1.326. Okay, and now let's actually see what the question says. It says find the exact maximum value of this. Okay, so if I want to maximize sine, the sum of the first 9, if I want to maximize this function, then I need to think about the bit that varies. And the bit that varies is the cos of x minus 1.326. So to maximize that blue part, the cos part, well, the maximum cos can be is 1. So the maximum this whole function can be is just when cos is 1. So this is the exact value. That's 4.5 times 2, which is just 9. So it's 9 root 17. Yeah. Okay. And now it says deduce the smallest positive value of x for which this maximum value occurs. Well, once again, when I'm maximizing this function for S9, I want cos of x minus 1.326 to equal 1. That's where my maximum occurs. So trying to solve this equation for x is going to give me cos to the minus 1 of 1. And we know that cos to the minus 1 of 1 is 0. So therefore x is equal to 1.326 by solving that equation. Bosh. Great question, that. Okay, question number 9. We've got a set of parametric equations and we want to show that it can be written in a Cartesian equation, y equals. So we've got a y equals equation up here, but the problem is it has a t in it. So it'd be great if we can just take a t from here and sub it in to here. But the problem is that we've got t squared and we've got 6t, so we've got a quadratic. But if we want to turn a quadratic into, well, we want to change the quadratic so that only the variable occurs once, then we complete the square. Okay, so what we're going to do is we're going to say x is equal to t, and then half of 6 is 3 squared, and then minus that value squared, minus 16. So that's how we complete the square. So this is t plus 3 squared, minus 9 minus 16 is minus 25. Okay, we're then going to need to rearrange to make t the subject. So I'm going to add 25, like so, and then I'm going to square root. So let's just do it like this, just to save a bit of time. Square root, like so. Okay, and then, technically we should have a plus minus here, but I'm hoping that that's going to get taken out. So I'm minusing 3 to both sides, so I get minus 3 plus minus the square root of x plus 25. Now the square root function is always positive, and we know that t, this is equal to t, sorry. We know that t has to be greater than minus 3, so this plus minus must be a plus, because we must add on a positive thing to minus 3 in order to keep t inside its own domain. Perfect. Okay, so we can write y is equal to 6 ln t is minus 3 plus the square root of x plus 25, and then we've also got this plus 3 here, which is very helpful because that of course is going to cancel with this minus 3 here. So we have that y is equal to 6 ln of x plus 25 to the power of a half, because the square root function is the same as raising something to the power of a half. And then by ln rules, if we have our input to the power of something, we can bring that down and become the coefficient. So we can multiply the coefficient by half here. So we get 3 ln of x plus 25. And that is exactly what we're looking for. It says A and B are integers to be found, so let's just say that A is 3 and B is 25. Perfect. Okay, part B. It says the curve cuts the y-axis at the point P. So that's important because we know that at that point x equals 0. And it says show that the equation of the tangent can be written in this form. Okay, so like we said, we know that x equals 0. And we also know that x is equal to, up here, t squared plus 6t minus 16. T squared plus 6t minus 16. So we can find the corresponding t values. And in fact, actually, to save time, we can just use this, can't we? Because this was the rearranged formula. So we can say that t is equal to minus 3 plus the square root of 25, because x is 0. Okay, great. So that's the t value at the point P. But we need to find the equation of the tangent. So in order to do that, we're going to need the gradient at the point P. So the gradient is the change in the y over the change in the x. So we need to differentiate the y with respect to t and x with respect to t. Because the gradient dy by dx is going to equal dy by dt over dx by dt. So differentiating the y1, this is a ln, so we'd have to use the chain rule here. So I'll just do it over here. So y is equal to 6 ln of t plus 3. So we can say that y is equal to 6 ln of u, where u is equal to t plus 3. So dy by du is equal to 6 over u, because ln u differentiates to 1 over u. And du by dt is equal to just 1. So multiplying these together to get dy by dt, we will get 6 over u. So 6 over u is 6 over t plus 3. Okay, so that's 6 over t plus 3. That is the derivative of y with respect to t. Now the derivative of x with respect to t is a bit easier, because it's just, well, here it is, here it's t squared plus 6t minus 16. So when we differentiate that, that's the x equation. With respect to t, we get 2t plus 6. Okay, we could simplify this, which I think is going to be important because we're subbing in quite a not easy thing to sub in. So we get this, we get this. Oh, whoa, whoa, slow down there. I should have simplified this, shouldn't I? Now that is easy, because root 25 is 5. So this just gives me t is equal to 2. Oh, fine, perfect. I got scared there, but no need to. This is going to be nice. So this is going to be 6 over, well, t is 2, so the first bracket is 5, and the second bracket is 10. So it's 6 over 50, which is the same as 3 over 25. Okay, so that's the gradient, and we know the t value, but in order to work out an equation of a line, we need the x value and the y value. So we know that at t is equal to 2, we know x is equal to 0. So what's the y value? Well, the y, as we said before, was 6 ln t plus 3. So at this particular point, it's 6 ln of 5, because 2 plus 3 is 5. Okay, so now we can do our straight line. y minus the y coordinate is equal to the gradient times by x minus the x coordinate of 0. So we get y is equal to 3 over 25x plus 6 ln 5. Just double check how they want it, not how I've given it. So they want the x's and the y's on the same side, and they want it as integers. Fine. So we're going to multiply through by 25 to get 25y is equal to 3x plus 150 ln 5. And then we're going to move over the 3x like so. And that is good. Just being pedantic, but they had it written this way round. Okay, job done. Okay, question 10, and it says express f of x in partial fractions in terms of k. Okay, so no problem. So f of x we can write as 3 kx minus 18 over x plus 4 x minus 2, and we could say that that is identical to a constant a over x plus 4 plus a constant b over x minus 2. We can multiply through by that denominator to get 3k minus 18 is equal to, the x plus 4s will cancel out, so we'll just have to multiply the a by x minus 2. And here the x minus 2s will cancel out, so we'll just multiply the b by x plus 4. Okay, we can then let x equal 2, because it will solve the bracket of x minus 2. And when x is 2, we'll get 6k minus 18. The bracket multiplied by a will go to 0, so therefore we don't need to write that. And then when x is 2, we'll get 2 plus 4 is 6, so 6b. And then we can divide through by 6 to get k minus 3 for b. Okay, we can then let x equal minus 4, as that will solve the other bracket. Subbing into the left hand side is going to give us minus 12k minus 18. Subbing into the first bracket, a x minus 2 will give us a times by minus 6, so minus 6a. Divide through by minus 6 to get a is equal to 2k plus 3. Perfect. So up here we can say that this is, well, the a is 2k plus 3 over the bracket of x plus 4, and b is k minus 3, which is over the bracket of x minus 2. Okay, so there we go. That is expressed as partial fractions. Okay, part B, and we have to integrate f of x between 1 and minus 3 dx, which is the same as integrating each of these partial fractions separately. So 2k plus 3 over x plus 4 and k minus 3 over x minus 2. Now I should put these in brackets to show they're both going to be integrated with respect to x, like so, and I should also put the limits here. Okay, so this is fine. Now what we do when we have partial fractions integration is we check that what the derivative of the numerator is. Oh, this is equal to 21, by the way. So the derivative of that numerator is 1. So ideally, I would like to have 1 over x plus 4, because that means we can integrate that directly into ln of the denominator. Well, I can't do that if I just pull out the constant term, which is on the numerator, which looks like this. Okay, so that works perfectly fine. So we're going to do that. And then again, for this next one, it's exactly the same. I want the numerator to be 1. So if I just take out a factor of this, which is a constant, and you're allowed to do it, but only if it's a constant, then we'll get 1 on the top and x minus 2. Okay, fine. This means that we're going to get 2k plus 3, let's put that in brackets, ln of x plus 4. And then plus k minus 3 ln of x minus 2. And I put these modulus signs around because when we integrate lns using the ln rule, we need modulus signs around the inputs of the ln. And this is between 1 and minus 3, and that equals 21. Okay, now we're going to need to substitute in. So I'm going to say we're going to have 2k plus 3 lots of ln 5, that's when we sub in 1 over there, plus k minus 3 lots of ln of, when I sub in 1, I get 1 minus 2 is minus 1. But because of the modulus sign, we can turn this into just ln of positive 1. So this just becomes ln of positive 1. And then that's the first limit substituted in. So I'll put a red bracket around those, because then we're minusing the second limit, which is when we sub in minus 3. So this is 2k plus 3 lots of ln minus 3 plus 4 is 1. So that's ln 1. And then this is plus k minus 3 lots of ln of minus 3 minus 2 is minus 5, but again, because of the modulus, we can turn this to positive 5. Okay, great. So, what have we got? Well, we've got ln 1s, and ln of 1 is 0, so that and that both are going to cancel. We can do some factorising here, because we've got two terms, this one, which has a ln 5, and this one, which has a ln 5, and they are subtracted. So I can say this is ln 5, open brackets, the one on the left, subtracted the one on the right. So she's doing some factorising. Okay, so then expanding out the brackets inside this square bracket, we're going to get 2k minus k, so that's 1k, and we're going to get 3 minus 3 is plus 6, and that equals 21. So we need to find the exact value of k, so we're going to divide through by ln 5 to get k plus 6 is equal to 21 over ln 5. So therefore k is equal to 21 over ln 5 minus 6. Bosh. Okay, we've got looks like a differential equation, rates of change type question. A tank is the shape of a cuboid being filled with water. The base of the tank is measured by blah 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 blah. Yep. Starts flowing into the tank, and the height of water was h, sorry, and then the volume of the water in the tank was v. In this model, the size of the tank and nature of flickers, yes. The rate of change of v is inversely proportional to the square root of h. Show that. Okay, so let's start with that. The rate of change of v. So the rate of change of v is dv by dt. And we are saying that that is inversely proportional, so proportional to 1 over the square root of h. So we know from our proportionality rules that we learnt at GCSE that that means that this is equal to some constant k over the square root of h. Okay, fine. Now, that's not what they've asked us for. That's the rate of change, of h. So we need another formula that links v and h. So the volume of the cuboid is equal to the base times by the width times by the height. So the volume of the cuboid is equal to 200 h. And that's the water, the volume of the water, not the volume of the cuboid. It's not filled yet. And we can differentiate this, so we can say dv by dh is equal to 200 when we differentiate with respect to h. So now, if I need to find dh by dt, which is what I've been asked to find, then I have dh over dv by taking the reciprocal of the equation we've just found, and then I can multiply that by dv by dt, which also I have found at the top, and that will therefore cancel out the dv's like this and give us exactly what we want. So I'll need to do 1 over 200 multiplied by k over root h. So with this dv by dt being what we found here, and with this dh by dv being the reciprocal of this. Okay, so that's good because that is essentially what we're looking for. So we're saying that the constant of proportionality over 200, if that was equal to lambda, just any given constant, it's just a constant, and k is a constant, and so is 200, so it's equal to a constant, which we'll just call lambda. Then means we can rewrite this as dh over dt is just equal to lambda over root h, as they've asked for. Perfect. Okay, moving on to the next part, it says given that initially the height of the water in the tank is this, and then exactly 8 minutes after the water started flowing into the tank, the height of the water was this. Use your model to find an equation linking h and t, giving you an answer in this form where they're constants to be found. Okay, so obviously this relates to the previous question that we've just done. And the one thing we do need to check is the units. So it does say here that t is measured in minutes, and we were given minutes, which is great. And volume is meters cubed as well, and height is in meters. So I think that all checks out. I don't think we need to do any unit switching. No, we don't, so that's quite helpful. Okay, always good to check that first, I find. So this is what we found from the last part of the question, and we can rewrite this as dh is equal to lambda dt over the square root of h by just timesing through by dt, and then we can times through by root h as well, so we get root h dh is equal to lambda dt. Now we do that because that allows us to integrate both sides like so, and form an equation. So the integral of root h, well, root h is the same as h to the half. So we're going to up the power to h to the 3 over 2, so up the power by 1, and divide by the new power, so dividing by 3 over 2 is the same as timesing by 2 over 3. And then on the right hand side, we're integrating with respect to t, so the constant lambda will integrate to lambda t, plus there will be another constant of integration which needs to be factored in, given the fact that we have just integrated. So let's just call that little c. Okay, now we need to use our two initial conditions to work out both of the constants, lambda and c. So the first one is that initially, that means that t equals 0, the height of the water is equal to 1.44. So we're going to sub that in. So we're going to get, and we're going to use our calculator for this. Okay, so we get 1.152 on the left hand side there, and that's equal to, well, t is 0, so therefore just c. Okay, perfect. And then we're going to use this next part. This says exactly after 8 minutes after the water started flowing in the tank, the height of the water was exactly 3.24. Okay, so again, let's sub in. Okay, so we get 3.888, and that's equal to lambda times t, but t is 8 in this instance because the time is 8, plus the c value we know now is 1.152. So to find lambda, we will just subtract the 1.152, and then we will divide that by 8. Okay, great. So there we go. Lambda is equal to 0.342. So therefore, the formula which we're looking for, the model, is going to be 2/3 h to the 3 over 2 is equal to lambda is 0.342 plus, no, that's times by t, plus c, which is 1.152. And then we're going to have to multiply by 3 and then divide by 2. Okay, so I've just done that. I've just multiplied this 0.342 by 3, then divided it by 2. And this has given me 0.513t. And then I also have to multiply that other constant over there, so 1.152 by 3, and then divide it by 2. Okay, so we get plus 1.728. Job done. Okay, and the final part of the question says, hence find the time taken from when the water starts flowing in the tank for the tank to be completely full. We're going right back up to the diagram. We can see here that the tank would be full when the height is equal to 5, because the height of the cuboid of the tank is 5. So we're going to say let h equal 5, and then we're going to try to solve for this. So the first thing we'll do is just do 5 to the power of 3 over 2, like so. So we get 11.18 is equal to 0.513t plus 1.728. And then we're just going to solve this equation. So minus 1.728 and then divide by 0.513. So we get that the time is equal to 18.4, and we'll put this as minutes because that was the units that we were using. Beautiful. Okay, we've got a modulus question, and importantly, it says that the number of subscribers are in the thousands, so make sure you highlight that. We've got two different lines on there. Now what I'm going to do is I'm going to colour them blue for this first one. So NA I'm going to colour blue. Now it has two parts to it. So it's got this part here that has a positive gradient. So in order for us to make NA have a positive gradient, we would take the modulus part and just keep it positive. Okay, wouldn't swap it over, wouldn't change the signs, and that will give us a positive line, t minus 3 plus 4, which is just t plus 1, so have a positive gradient. Now, if we were to look at the other part, I'm going to do that a bit of a darker blue. This part here, that has a negative gradient. So to make that a negative gradient, I'd have to swap the modulus, everything inside the modulus to make it negative. And that'll give us minus t plus 3 plus 4. So that'll give us a negative gradient. Okay, let's do the same for the other one as well. This is going to be helpful for part B of this question. But it's good to just get the clarity now. Okay, so we'll do the lighter green. Let's do this one. Let's say it's this one. So there, that has a positive gradient. You can see that it's going upwards. Now, in order to make this equation of B have a positive gradient, we would have to make the modulus negative, such that we would have 8 minus 2t, which will give me 8 plus 2t, so it'd be a positive gradient. And then the other part of it, this one here, let's do this a darker green. So that's going to have a negative gradient because it's going downwards. And the only way that's going to happen is if we just keep the modulus positive. So then they'll end up with being 8 minus 2t minus 6, which gives us a negative gradient. Okay. Right, so we will use that for part B. I just wanted to do that first off because it's nice to know which part of the modulus graphs is which. It says find the difference between the number of subscribers to company A and the number of company B. The initial difference, okay, so fine. So the initial difference is when t is equal to 0. So NA will have 0 minus 3 plus 4, which is the same as the modulus of 3 plus 4, which is the same as just 3 plus 4, which is obviously 7. And then t equals 0 NB. That will be 8 minus the modulus of 0 minus 6, which is 8 minus the modulus of minus 6, which is 8 minus 6, because again the modulus turns any negative number to positive, which is 2. So therefore the difference, and this is where I'd be careful about the units, is equal to 7 minus 2, which is 5, but it's 5,000 subscribers. Okay, perfect. So 5,000 is the answer for part A. Okay, let's move on to part B. Now part B, it says that company A reduced its subscription prices and the number of subscribers increased. Suggest the value for T. Well, if we go here, this is clearly where the subscribers started to change, because it goes from being going downwards to start increasing. So where is that point? Well, if we look at the formula for NA, it's t minus 3 plus 4. That point here is the minimum point. So if we want to make the minimum point, then we're going to want to make this modulus part as small as possible. Now remember, it can only be positive, so the smallest it can possibly be is 0. So we want t minus 3 to equal 0, which means t equals 3. So capital T is equal to 3. It does say give a reason for your answer, and you can just say that this is the minimum point. So t equals 3 is the lowest point, the minimum point. Okay, great. Right, let's get rid of that. And then let's go on to the next part, which says find the range of values for which NA is above NB. Give it in set notation. Okay, so this is why I started this question using the colours to answer this part of the question. So we are looking at when NA is above NB. So that happens over here. NA is above NB, and over here, that's when NA is above NB. So we really need these intersection points to know when the changeover is. Now to find these intersection points, I'm going to use the colour system here, because there are actually additional intersection points. If these lines that we've drawn in colours carried on indefinitely, then they would intersect at other points as well. So the one we are looking for at the start is light green crossing with dark blue. Okay, so this is when they are both, we have to take the negative of both of them. Okay, so we can do that. So taking the negative of the modulus of the first one is going to give it minus t minus 3 plus 4 is equal to 8 lots of minus, I'm taking the negative of the modulus, like so. Okay, so let's solve this. So minus t plus 3 plus 4 is equal to 8 plus 2t minus 6, which is going to give me 7. I'll add the t to the other side, so 3t, 8 minus 6 is plus 2, so that equals 5. So divide through by 3, t is equal to 5 over 3. Okay, great. So let's move that out of the way, give us a bit of space. And now the other one we're looking for is when we've got the dark green and the light blue. So this one and this one, when they're both positive. Interesting. So this is t minus 3 plus 4, just keep that positive, is equal to 8 minus, and just keep this exactly the same, like so. So this gives us t plus 1 is equal to 8 minus 2t plus 6. So that gives us 3t plus 1 is equal to 14. So 3t is equal to 13. So t is equal to 13 over 3, like so. Okay, great. So we've got the two critical points. Now, the yellow area, which is what we're actually looking for, is when we are to the left of this first critical point and when we are to the right of this second critical point. So, in set notation, we have to say that it is t, where t is less than the first critical point, union with t such that t is greater than 13 over 3. Okay, and that is our final answer. Okay, then it says state one limitation of the model used for company B. So company B goes up, which is fine. It comes down, then it's just going to continue going down like that. So there's going to be a value at which it's going to become negative, which is not possible. I guess we can find that value by setting the number of subscribers equal to 0, like so. Then we can say that 8, so minus 2t plus 6 equals 0. So 2t equals 14, so t equals 7. So the answer is that the limitation is that after t equals 7, the subscribers the subscriptions become negative. Okay, job done. Okay, question 13. And we are working out this binomial expansion. So what we're going to need to do first is we're going to need to make it so that it is 1, the constant term is 1 inside the bracket. So we're going to pull out a 3 as a factor, and when we pull out a factor from a bracket, we have to take the power with it, which allows us to divide inside the bracket by 3, like so. Okay, now the formula is 1 plus nx plus n minus 1 over 2 factorial x squared. We only need the first 3 terms, so obviously it goes on infinitely, but that's all we need for this. So it's 1 plus, so the n is the power, which is minus 2. The x is, in this case, x over 3, like so. And then plus, whoops, let's just, don't forget to keep the 3 to the minus 2 outside, like so. And then we have n, which is minus 2, n minus 1 is minus 3, and that's all over 2 factorial, which is 2. And once again, the x is x over 3, and that needs to be squared. Okay, so this is 1/9. Let's just write that like that. Then we have 1 minus 2x over 3. The 2 and the 2 will cancel, but don't forget the 2 minuses will add together to make a plus. And in fact, we're going to get 2 3's on the bottom from the x over 3 squared. So that's going to cancel with one of those. So we'll just have x squared over 3. To double check, I think that's right. Yes, that's all good. So we get 1/9 minus 2x over 27, and then plus x squared over 27. Perfect. Okay, lovely. Okay, so for part B, I'm going to use this answer to part A, so I've kept it up here. And we're going to take this integral, and we're going to just rewrite it as, so let's call this the integral I, and we're going to rewrite it as 6x to the 3 plus x to the minus 2. So we just brought the bracket at the bottom up to the top, changed the power to a negative. Now this is approximately equal to the integral of 6x multiplied by our approximation for this bracket, which we did in the previous part, which is 1/9 minus 2x over 27 plus x squared over 27. Okay, so this is approximately equal to, again we can expand out these brackets. 6 times a 9th is 2/3, so that's 2/3 x. Timesing through by 6 is going to give us minus 12 x squared over 27. And again, timesing through by 6 is going to give us plus 6, and then the x cubed, which is times through by x as well, over 27. Okay. Lovely. And now we need to just substitute in these values after we've integrated, of course. So we up the power and then divide by the new power. So up the power gives us x squared. Divide through by 2 is just going to give us a third. We're going to up the power to 3. We're going to divide by the new power, so that's going to give me 4x cubed over 27. We're going to up the power to 4, and then we're going to divide through by 4, which will give us 3 over 50. Dividing through by 4 gives us 3 over 54, x to the power 4. Okay, and then we're just going to sub these in. I'm going to have to use my calculator to do this. Okay, I've just subbed those all in. Very boring, so I don't want to waste your time watching that. It comes up 0.0330337. So again, that's approximately, because we're using an estimation, which again is approximately 0.03304 to 4 significant figures. Okay, perfect. Right, on to the next one. It says find using algebraic integration the exact value. Okay, so what we can do then is we can do this two ways. We can do by substitution or by integration by parts. I might do both, but my gut is telling me that substitution will be easiest. We can't use reverse chain rule because the brackets derivative isn't 6x or anything like 6x. The brackets derivative is 1. So let's use substitution. So this is what I need to do. 6x over 3 plus x all squared dx. So I'm going to say that u is equal to 3 plus x. So it's the denominator, which is the problem piece. If we can clear that, then we'll be good to go. So du by dx is equal to 3 differentiates to 0 and x differentiates to 1. So du equals dx, which is nice and handy. It does mean that we need to change our limits, though, which is a bit annoying, but relatively straightforward because when x equals 0.4, u equals 3.4. And when x equals 0.2, u equals 3.2. Okay, and I think the last thing I'd want to do is just write that x is equal to u minus 3. Could be useful when we're substituting to the numerator. Fine, so this integral is equal to the integral of 3.4, 3.2, 6 lots of u minus 3, because it's 6 lots of x, over u squared. Du gets swapped out directly for dx. Fine. So let's now simplify this. We've got on top 6u minus 18 when I expand that out. So that's 6u minus 18. We can split that numerator up into two separate fractions. So the first one will be 6u divided by u squared, which is just 6 over u. And the second one will be minus 18 over u squared, which is just the same as 18u to the minus 2. Okay, great. So the first one integrates to ln 6 ln u. And this next one, up the power to minus 1, divide by minus 1, is going to give us 18u to the minus 1. And then we've got to sum in 3.4 and 3.2. So what I'll do is I'll write this out like so, just to show the examiner that I'm summing in, plus 18, that's the reciprocal, so over, like so. That's the first one, then minus the second one, which is 6 ln 3.2, plus 18 over 3.2. Okay, perfect. So let's look at the lns part first. Both of them have a factor of 6, so we can take that out. And then what we're going to be doing is we're doing ln 3.4 minus ln 3.2, like so. And then the numerical parts will be 18. We can just do that on our calculator. Okay, so there's the numerical part. I say numerical. There's the non-ln part, which gives us the minus 45 over 136. So minus 45 over 136. And then finally, what we need to do is we need to divide the inputs of these lns, because we've got two lns minus each other. So we just do 3.4 divided by 3.2, which gives us 17 over 16. So it's ln 17 over 16, and then also minus this 45 over 136. So yeah, you could do substitution or integration by parts. I just picked substitution, and there's your answer. Okay, a tricky trig question. And the first thing I've spotted here is we've got 1 plus tan squared. And as we should know, we have cos squared plus sine squared equals 1. And you can divide this identity through by cos squared theta. And that gives us the other identity, or another identity, should I say, which is 1 plus tan squared is equal to sec squared theta. So we're going to use that. We're going to rewrite this like so. 23 sine squared is equal to 8 sine 2 theta. I'm going to want to keep that sine 2 theta because I can see there's 1 in my answer. And that's multiplied by sec squared theta. So to clear a sec squared, because it is 1 over cos squared, means we can multiply through by cos squared. Also, I know that tan is sine over cos, so let's write it like that. And we're going to multiply through by the cos squared. And that's going to give us this. Okay, again, I want to keep the sine 2 theta. I don't want to expand that out because I know there's going to be a sine 2 theta factor in my answer. But what I can do is I can now cross off a cos here and cancel with that cos there. And also I can see that in my answer there's only coses. So I need to swap out this sine squared theta with a 1 minus cos squared. Again, using the original cos squared plus sine squared equals 1 identity. So we get 2 sine theta cos theta here, 8 cos theta plus 23 1 minus cos squared theta is equal to 8 sine 2 theta. Okay, great. Look at this. Sine 2 sine cos, which is the identity for sine 2 theta. Perfect. And in here we're going to have 8 cos theta plus 23 minus 23 cos squared theta. And that's equal to 8 lots of sine 2 theta. Okay. So what we can do now is we can say how many sine 2 thetas have we got? We have 8 cos thetas of them. We've got 23 of them. We've got minus 23 cos squared theta of them. And then when we move this to the other side and then factorize out the sine 2 theta, we'll have another minus 8 of them. So I can say we have another minus 8 sine 2 thetas in total, and that equals 0. Okay, so now we can bring it all together. We've got minus 23 cos squared. We have plus an 8 cos, and we have plus 15 equals 0. Perfect. So we can say that A is equal to minus 23, B is equal to 8, and C is equal to 15. You could have also moved it to the other side, and all those numbers will be the negative of that, which is also correct. Okay, so part B is asking us to solve the exact equation, but just instead of a theta, we've got x, and x is between 360 and 540. Okay, so instead of solving that equation, we're going to solve the one we've manipulated. This part could be 0, so we have sine 2 theta could equal 0, which would mean that 2 theta would equal 0, or when is sine 0? Let's think of the curve. It's 0 at 0, 180, 360, and 540. And let's keep going. It's also at 720 and 900, and also at 1080. Dividing through by 2 gives us 0, 90, 180, 270, 360, 450, and 540. So that's up to the top of our range because the range is between 360 and 540. So perfect. It means that these ones are outside the range, but these three are good. But are they? Let's double check. It tells me that x cannot be 450. So 450 is no good. And I've just realised that actually, this new equation is in terms of x. So let's write it as 2x, 2x, and these are our x values. Okay, so how else can we make this equation equal to 0? Well, if this part over here is equal to 0, this part of the bracket. Okay, let's come around this side. Nice. So that's a quadratic. So we'll need to solve that quadratic, and I'll use my calculator to do it, which I think is fine. In order to solve it, I can say, let's make it positive 23, negative 8, and negative 15. So we get 1 and minus 15 over 23. So perhaps, just to show the examiner that I know what I'm doing, I'm going to actually factorise it. So let's just make it so that the square term is positive like I did on my calculator. And now I know that it's going to factorise nicely. I can write it like so. And the other one was minus 1, like that. Sorry, that should be a positive. Okay, just double check that works. Yes, that does work. Okay, good. And the reason why I'm doing this is because I'm just slightly concerned that it does say make sure that you use calculator technology. So I'm just showing them that I can factorise without the calculator. And this gives me cos is equal to 1. Okay, so I need to check that I'm in the correct mode, which I'm not. So let's go into degree mode. And then let's go into here and let's do cos to the minus 1 of minus 15 over 23. And we get theta is equal to 130.7. Now the second solution for cos, we do 360 minus. That's how we find the second solution. For cosine, for sine it's 180 minus, for tan it's 180 plus. Okay. Now for each of these, we can add on 360 because we go around the unit circle one full turn. So I can add on 360 to this one, which is actually outside of our range because we're only allowed to go up to 540. But I can also add on 360 to this one as well. So you find the first solution from your calculator, the second using a formula, and then any additional ones you can add or subtract 360. So therefore, this one needs to go, this one needs to go, and this one needs to go. So this is the only one in the acceptable range, as stated in the question. And then finally, this solution here, cos of 1 is 0, and 360, just thinking about the graph, and also 720. So the only one that is acceptable is this one, which we've already got over here as well. So these are our acceptable answers. Again, I've used theta, but I think it's fine. X is equal to 360, 490.7, and 540. Perfect. Let's just change these to x's because I don't want anyone getting upset with me in the comments that I'm solving the wrong equations. There we go. Everyone's happy. Yay. Okay, so we have a proof question, and it says that a student started this proof. It says that given that x is an obtuse angle, use algebra to prove by contradiction that sine minus cos x is greater than or equal to 1. The student starts with this proof, which is assume that sine x minus cos x is less than 1, when x is obtuse. That's good. That's the negation of the original statement. Squares both sides. That's fine. Okay, so now we need to just carry on the proof. Fine. So we're going to expand out the brackets. So we're going to get sine x minus cos x times sine x minus cos x is less than 1, which is going to give us a sine squared x. It's going to give us 2 minus sine x cos x's, and it's going to give us a plus cos x squared. Now this is going to be 1 minus 2 sine x cos x, and I'm just going to write here as sine squared x plus cos squared x is equivalent to 1. So we just swapped out the sine squared plus the cos squared for a 1, and just written down the identity next to it. It's just nice. It's a proof question. You want to give as much information as possible. So this is equal to sine 2x. We know that from our double angle formula. So 2 sine x cos x is sine 2x. I'm then going to move the sine 2x to the other side to make it positive. And I'm going to subtract 1 from both sides, like so. And I'm just going to write it the other way around, because I just prefer it written that way around. Okay, so now we're going to have to use the fact that x is an obtuse angle. So we can say that as x is between 90 and 180, then the angle we're looking at is 2x, so that's between 180 and 360, which is reflex. That's a reflex angle. Okay, so let's look to see what happens for sine of an angle which is reflex. Well, if you have an understanding of the cast diagram, we know that all trig functions are positive between 0 and 90. Only sine is positive between 90 and 180. And then the ones down here and down here, well, this one here, tan is positive, down here cos is positive. So sine of 2x is negative for x obtuse. Therefore, we have a contradiction. And the original statement, which was sine minus cos x is greater than or equal to 1. Sine x minus cos x is greater than or equal to 1 for x obtuse. Is true. Perfect. Right, I hope you enjoyed that, and I'll see you in the next one. Bye for now.